Now Purdue is going back. So there's two things that could be going on here. One, the students could be playing. Or two, this robot is in fully autonomous mode and it is doing its own thing. Only the judge in the control room knows for sure whether they're fully autonomous or whether they're manually driving this robot around. So these are the last two teams that have been able to compete. It's possible that these robots are not fully functional, and that's why they've waited till the very last slot to put these robots in to try and give them a chance to get their robots completely working. And so that may be what's happening here. It's possible that the Purdue students are just playing. It looks like one of the students, I don't see a joystick. No, yeah, he's got a joystick in his lap. So I'm fairly certain that these Purdue students are using this 10-minute run in order to gain some driving experience, in order to test their robot. These students don't have, you know, hundreds and hundreds of pounds or thousands of pounds of this crushed volcanic rock back at their school. So they're not going to waste this opportunity. If their robot drives, even if it can't dig right now, if their robot drives, they are going to drive it, because this is experience that you can't get anywhere else. There's a wire that's hanging down there that might be telling that the robot is not completely in working order. But the students knew that when they came in, because they were right out of the bat, flying through the obstacle field, driving over a rock right off the bat. So this is really good information for this team to find out how well their robot maneuvers in this crushed volcanic rock. They're being able to collect data at this point, visual data and, you know, actual digital data, and see how well their design that they have spent all year designing and putting together and testing. This is just another test for this team at this point, but it is probably one of the best tests that they will ever be able to perform with their robot driving around in this crushed volcanic rock. 3.5 minutes in, 6.5 minutes remaining for these two teams. It's great to see this robot. Now that I'm about to say it, it has a high enough ground clearance that it can get over those rocks. Some of the robots cannot do that. So not only can this Purdue robot just straddle these rocks, it can actually drive the wheels right. Hey there, hello there. It can actually straddle these rocks. I mean, it can actually drive over the rocks, hit them with the wheels. So right now this robot's a little front heavy because of its digger, the way the digger is deployed. So it's giving us some wheelies there, show off. So I'm not sure if their dumper mechanism is working. They had a chance to show that off there, but I didn't see anything move. It's possible their dumping mechanism is not working right now. But as far as driving and locomotion and moving around on this crushed volcanic rock, look at that wheel in the lower left. This material could really make your wheel dig in, but the way this robot is designed, that's not happening. These wheels are not digging in. So this team has definitely got some success with the design of their wheels, their locomotion system, their suspension. Everything seems to be working for this team except for the digging and the dumping, obviously. So regardless of the score, this team from Purdue should be really proud of what they've done just by watching this robot drive around that arena. We see so many robots get stuck when they drive in this stuff. So it's really impressive to see a robot drive so freely and carelessly in this crushed volcanic rock and not even care about getting stuck. This robot hasn't even come close to getting stuck in this simulated regolith. Is that me? Is that me? I think that's me. Wheelie mode. 3.5 minutes remaining to play for Purdue. To play and show off. And it is quite a show because we have seen so many robots just get bogged down and get stuck. We've seen robots get stuck on rocks. We've seen robots get stuck in the craters. We've seen robots get stuck just on the flat area, just digging in their own wheels and not moving a bit. So something is working really well on this robot, and its its mobility system. You can see the large fins. That may be a factor in what's giving this robot such great mobility. Some of the teams use really wide wheels. Some of them use very thin wheels. I'm not sure which is better. It's hard to say. There's so many variables there. Another thing you'll notice is that there's large open areas on these wheels for the material to not get bogged down in and not get stuck in. So that could be a factor when this robot turns and these wheels push sideways against the material. The material doesn't get bogged down and built up because it can flow right through the holes in these wheels. Look, they're trying to get stuck now, and this robot just is unable to get stuck in this material, which is amazing to see. 2 minutes left. Sadly, we haven't seen the Morgan State robot move in this run, their last run of the competition this year. Minute and a half now remaining of playtime for Purdue. So, for those watching online, make sure you come back at 7 p.m. Eastern Time, and you'll be able to watch our entire award ceremony this evening. You'll be able to see all these students celebrate the week that they've had here. There are no losers in this competition. We make every effort to give each one of these teams, each one of these students a good experience and a fun experience. And regardless of the final score, all of these teams come out and say, I've really learned something, I've really enjoyed myself. And so, you know, that's really the main goal of this competition. Not only are we advancing these technologies that NASA needs to use someday, but we're giving these students really great engineering experience that is really second to none. This experience they can put on their resumes really gives them an advantage over other students that don't have this sort of experience. 30 seconds remain for Morgan State and Purdue, the last two teams that are competing in the event this year. This is the 9th year in a row we have put on the NASA Robotic Mining Competition, and we will strive to continue putting on this competition as long as it keeps giving us really good payback. As long as we continue to advance these technologies, we will continue to put on this event. All right, as time winds down, let's give Morgan State University and Purdue University a big hand. Very impressive robot there, Purdue. So don't go anywhere because we're going to